Good afternoon. Just like Steve mentioned, let's talk about DU. DU handle most of the data in physical layer get from radio unit and the using off-the-shelf server. I'm working for MiTAC, which is a server company in Taiwan. So that's the reason I bring this topic. This is Alex. Firstly, let's talk about two typical use cases for the RAN. I think we just talked about the RAN on the cloud. So CRAN is one of the deployment. On the other hand, there is another kind of deployment, we call it DRAN. The major difference is CRAN is put the DU-CU. You can see this small drawing. The DU and the CU are more close to the edge cloud. The DRAN, DU is more close to the cell side. So while we saying we can use DU by off-the-shelf server, actually we need to define the off-the-shelf server. I give you two typical examples. Let me use my computer. Okay. The one on the top is a typical configuration for the CRAN. So the configuration, for example, it can be one socket or two socket. Typically, it's using 32 core. The memory size is not much spatial. It will be 128 or 256. About the NIC, we usually use 25G for the front haul, 10G or 25G for the back haul. And while we say we do the cloud native, so we put the virtualization software on top of the servers. While we need to install the DU at far edge, I will say near the tower, the configuration is actually different. You can see the server itself much light than the server on the cloud. For example, we typically define one socket only. The core count can be a little bit lower, 24 to 32. Memory probably the same. NIC also the same, 25G for the front, 10G or 25G for the back. And as a DU, it needs to handle physical layer just like I mentioned. So it needs layer 1 and layer 2 software on top of it. The major highlight here is to run the DU software, we probably need additional FEC or accelerator, like something like that. Besides, you can imagine if you install a server on an outside cabinet, you probably need more I/O to measure that. For example, we put some alert I/O there, so people in miles away, they can know what happened for the outdoor cabinet. Besides, because you put that outdoor in a cabinet, the environment requirement is much typical, much challenging than the one in the data center. So we will do the server meet NAPS spec. Example is, while you use a server in the data center, the temperature probably only needs 35 degrees for the operating temperature. But if you want to run a DU outdoor, it probably need to handle up to 55 degrees. So that's a brief for the CRAN and DRAN. And right now we have two kinds of customers, or you call it an ecosystem in Europe. The one on the top is our CSP customer here. So we are talking about some idea about use OCP server in their cloud data center to achieve what we do for CRAN. On the other hand, we also work with the other partner rapid space to promote the outdoor DU I just mentioned, 45H. Then let's talk about how we migrate current version to next version. Because while we keep push the O-RAN to 5G or even 6G in the future, the hardware itself also migrate from generation to generation. So that's also talk about something for CRAN and the DRAN. For CRAN, we use the computing power on the edge. So the next generation usually need higher computing power. So that's the basic concept. Also add more accelerator. And if you talk about the DRAN, we are thinking more things. We try to, things we already make an effort to put the server at the 5G, we try to make it have more functional. For example, some deployment is 5G non-standalone. So we will try to make the same server can be used for both LTE and also new radio. On the other hand, also try to use different acceleration technology. For example, there is inline accelerator or look-aside accelerator. The major difference is if it consumes CPU power. So different, we call it ISV. Different ISV may require different solution for the acceleration. So again, CRAN first. Right now the server we shipped or we contribute to the OCP marketplace is on the left. It's a 2OU 3-node platform. So I list the major spec on the left. And the one on the right is a new generation.
Alex, sorry, can you make sure you're in front of the mic, or if you need the handheld, because we're recording it and you're.
Oh, okay, got it. Let me try to.
Okay.
Okay. So the one on the right is the new generation. So you can see we migrate from 1 socket per node to 2 sockets per node. In that case, we can increase the CPU number to 2.6. Also for the GPU card density, the one we shipping now is 3 pieces maximized in 2OU because you can see there are 3 nodes. So we can install 1 GPU per node. So there are 3 for now. And for the future, we will put 4 GPU on top of the node. So we can migrate from 3 to 4. We do this way to make our CPU number and the GPU number increased. And for the DU for outdoor, right now on the left is the spec I just mentioned. And for the new one, we will increase the CPU core count and also increase the FEC performance, higher LAN bandwidth. And one special feature is we try to make it can be used for DU and also MEC edge server. I will tell you more in following slide. The photo I show you here actually is 2 server with the same motherboard, but with different I/O. The one on the top is the one for DU. The one in the bottom, you can see the difference. I changed the DC power to the AC power. I also add more local storage. So the server with the same motherboard can use this way to be DU or edge AI server. While we do the edge server, we also consider the modular design. As you know, for the data center, people are talking about the DC-MHS. While we do the edge design, we also think in a similar way. So we are thinking leverage the DC-MHS. For the Open RAN, people are talking about the open interface. And we can get advantage for the modular design is it is easier for migration. For example, while we do the next generation, I only need to change one of the module. And it can be multiple function. Just like I mentioned, it can be DU or it can be edge AI server. Just in case I list some DC-MHS spec here, to let you know, we leverage this spec for the edge design. following two slides is to show you how we make it happen. Each block you've seen actually is a module which can be either pop on the motherboard or depop on the motherboard by bond option. So the first you see now, we put all this module on the board. For example, the timing module, the DC-SCM module, the DC power module. In that case, we can use this design for the DU. If I remove the DC module, change it to a power supply, I remove one of the NIC and leave the space for local storage, for example, like a E1.S, then I can have some storage in this server. Then we can use this server for the edge AI purpose. And for DU itself also can be configured for different RAN scenario. So I list the 4 scenario here. It can be configured by either different accelerator card. For example, you can use Cadbury card, you can use the FEC card, you can use other inline accelerator card. Also different NIC configuration. So you can use the same server, different configuration by this way to achieve different RAN split. Also, I list a table to show you how we configure to 5G standalone or 4G or edge AI server. I take this timing as an example. For example, only DU need a timing module. So for timing module, I can install on the 5G, 4G server. But if you use it for edge AI server, you don't need this module. You just simply remove it. All right, here I show the OCP marketplace we contribute. It's mainly for cloud RAN. So we have a half-width node and also an open edge node. So we are talking about talk to the cloud CSP customer to use this OCP server for the cloud RAN. And in this year, we will contribute the outdoor DU I just show you to OCP, so we can have both kind of DU available on the marketplace. All right, so we should keep work together to try to make this market become bigger and bigger, then we can enjoy that. Thank you.
Thank you, Alex.